What we wanted to do here in the next set of presentations is highlight some of the outstanding international research collaborations that we have here at CUNY underway. And we've identified 3 projects, okay, to do that. The first presenter is Masahiro Kawaji. The second presenter is Michael Mirkin. Masahiro is from City College. The second presenter is Michael Mirkin from Queens College. And the third presenter is Sunil Bhaskaran from Bronx Community College. So let's start with Masahiro, who's a professor of mechanical engineering at City College and acting director of the Energy Institute at the City University of New York. The institute is CUNY-wide. He received his MS and PhD from University of California, Berkeley, and has over 35 years of experience in conducting research on multi-phase flow and heat transfer, teaching chemical, mechanical, nuclear engineering courses. From 1986 till 2009, he taught at the University of Toronto, where he was acting chair of the Department of Chemical Engineering and Applied Chemistry in 2008. He's a fellow of the Canadian Academy of Engineering, American Institute of Mechanical Engineers, and the Chemical Institute of Canada. His research interests include multi-phase flow and phase change heat transfer, thermal energy storage, nuclear reactor thermodynamics and safety, microfluids, heat pipes, and microgravity fluid physics. Over the last year or so, I've gotten to know Masahiro very well. In fact, I worked very well. We worked with him and his team up there at City College to prepare a proposal for the PIRE award, a PIRE program, and we were successful in this round. And I owe a great deal of gratitude to his leadership skills. One of them is, I think, is a very innovative engineer in his thinking. Huge amount of respect from his colleagues up at City College. He's very much a team player, excellent manager, and I think he epitomizes the unique role of what it takes to successfully compete for an international project like the PIRE and be successful at it. So he'll talk to us a little bit more about PIRE. Masahiro?
Good morning. I hope you can hear me with this microphone. Before I start, I'd like to thank John for tremendous help he has afforded us in preparing this proposal. He gave us lots of tips to prepare a really good proposal. So our PIRE proposal is entitled Multi-Scale, Multi-Phase Phenomena in Complex Fluids for the Energy Industries. And it's a PIRE. PIRE stands for Partnerships for International Research and Education. It's a grant at $5.2 million over 5 years. And the foreign sponsors include Norway, France, and Germany. And I'm very glad to meet with the representatives of these agencies today. So the members of our PIRE team really come from City College of New York, from mechanical, and chemical engineering departments, as well as physics. So these are the people who are involved in the PIRE team. And we have Rob Messenger in the audience as well today. I'd like to acknowledge again, thank John for his assistance in providing support for preparing the proposal. Keiko Sometani at the grants office at CUNY, at City College, for looking after all the details of the application materials, especially the budget breakdown and so on. And we have just added Ms. Anna Volovic as the project coordinator at City College for the PIRE project. And she's here in the audience today. So we have 11, well, we have, I think, 9 collaborators from Norway, from this institute, research institute, and 2 universities in Norway. So we have reached out to them and got their agreement to participate and collaborate with us before we prepared the proposal. French collaborators from 1 or 2 national institutes and 2 universities, and also 6 researchers from these institutions. German collaborators, we have 6 from 2 institutes and 3 universities. So it involves 21 researchers from 11 institutions. So it's a fairly large program that involves a lot of international collaboration. So our vision in this pilot project is to accelerate research, education, and training in multi-phase fluid engineering science, and to develop a diverse STEM workforce by creating an international collaborative network with advanced research tools that exist in our partner institutions. So the objectives are to advance knowledge and make transformative scientific discoveries to improve energy and process efficiency in industrial systems on a global scale, to accelerate education and training of students and postdocs by providing unique opportunities in international research, and to build strong international partnerships by sharing resources and research infrastructure among the participating institutions. So our problem involves a complex fluid, and we're looking at multi-scale. This is a sort of very small length scale to very large length scale. So we have basically complex fluids that involve a continuous liquid phase, this one, and internal phase two. These could be droplets of immiscible liquids or solid particles, and then the network forming substances, phase three, which lead to the formation of these structures and network-linked multi-phase system, and they behave very different from pure fluids. And these complex fluids are important in different industries, including oil and gas industry. So the research themes, there are two research themes, one covering molecular scale phenomena in complex multi-phase fluids, so very, very fine scale, molecular scale. And the other one is macroscopic scale that govern transport processes and properties. So this would be more important in actual implementation or use of these fluids in industries. So we came up with this diagram that basically shows the theoretical approaches that would be used to probe very molecular scale phenomena and macro scale phenomena. And then the experimental tools that we would be able to use based on what's available in our partner institutions. Okay? And just on our own, it'd be very difficult. We'd be very limited to the type of theoretical tools and experimental tools that would be available just at City College. And be probing molecular phenomena like crystal and molecular structures, interfacial absorption and reactions, and structure and network formation, and microscale transport processes and rheology. These are the different scale phenomena that would be probing using these different theoretical tools and experimental tools, diagnostic tools. And we involve four different countries. Most of them involve 4 or 3. Thrust 1 is on asphaltenes, and thrust 3 on drilling fluids. These are of importance to oil and gas industry. And thrust 2, gas hydration, and thrust 4, phase change slurries. These are important in energy storage and transport. So we have 2 different application areas. And modeling and simulation, these are the tools that we would use to theoretically analyze the phenomena involved. So we have 4 different thrusts. These are research topics that we'd be working on. And each of these involve about more than 10 researchers from all the participating institutions. And I think we've achieved a very good balance among these 4 thrusts and the number of researchers and countries that are represented. So at least 3 of them, 3 countries are involved in each of these topics. And we will also apply modeling and simulation using advanced theoretical tools. So now this pilot proposal basically was built on prior collaborations, and I think it's important to have had some prior collaborations, before writing the proposal. So with France, I spent a year at one of the institutions in Paris, and then Professor Morris has a chair position at University of Toulouse. With Norway, 2 of our faculty members was involved in a flow assurance consortium over the years, and Professor Pochard was actually a project leader in that program before coming to City College. And with Germany, 2 of our faculty members had started their collaboration with the researchers, counterpart researchers at Karlsruhe and Dresden. So These collaborations have basically involve common research interests and complementary expertise and facilities, and that would lead to synergy and strengthening of our research competitiveness. Now, Norway, more specifically, Norway can provide us with samples of draining fluids and crude oil, and their very detailed knowledge about these industrial fluids. And France has a test facility for gas hydrates and very specific modeling capability. Germany offers unique computational and experimental resources as well. So we are benefiting from collaboration in different ways. Now, in the proposal, we prepared this table that illustrates the past collaborations with our college, with all the partner institutions in 3 different countries, and which areas of research we would be collaborating on in this column. And then we had to identify unique strengths of the partners. So that's not on paper. We have to know what they are very good at, what kind of facilities they can offer us, what kind of tools they can offer us. So we summarized those unique strengths in this column. In the next column, in the next table, we also try to identify mutual gains arising from the partnerships, because all of our partners have to gain something from this project. Okay, it's not just us gaining benefits, but they also have to gain. And so we try to discussed what they would gain and then listed them here. And then the number of researchers and number of students that would be involved are also listed in these columns, and the possible funding levels. But this is prior to the submission of the pilot proposal, so this was still somewhat of a preliminary estimate. And then our Norwegian partners applied to Research Council there, and they have applied for $3 million in funding over 5 years, and they have already got approval for about 1.1 million. Hopefully, this NRC will approve the rest of the funding in the remaining years. And Germany, they have applied for funding to their DFG for about 3 years, and then they will try to extend it for another 2 years after that. And then France and ANR, they just submitted their proposal for about 600,000 euros, and hopefully, there will be additional amounts, additional funding that will come for the remaining year and a half. Now, CNRS is the other agency, but unfortunately, CNRS says they will only fund bilateral proposals and not multinational. But I think I talked to, today I talked to the representative from CNRS, and I think hopefully, the CNRS will also support this pilot project. Now, we have several different educational goals, mainly to mentor and train outstanding undergraduates and graduates and postdoc researchers at City College and contribute to the development of the STEM workforce. So we will try to recruit undergraduates, master's, and PhD students from underrepresented groups at CUNY, and we will provide both undergraduates and high school students with opportunities for research experience and interactions with foreign collaborators. Now, this is a lot of text here, but some of the educational aspects are sort of broken down here, listed here. We will support 7 PhD students over 4 years each, and then 3 postdoctoral fellows. And so each postdoctoral fellow will be supported for 1 to 2 years. And 10 master's students, so 2 master's students per year for 5 years, and 10 undergraduate students would be recruited and supported over the 5-year period. And hopefully we'll be able to identify students from underrepresented minority groups, including women. So we'll do a very aggressive recruitment activity, including an annual weekend program for undergraduates and master's students. And Louis Stokes Alliance, this is another program CUNY has, will fund 2 undergraduate students to spend a summer at our international partner institutions, and they'll cover the cost. So this is a contribution by our LSAM program. And both our PIA faculty and our collaborators will mentor these students and enable them to work in the state-of-the-art research facilities, for example, at the Advanced Science Research Center of CUNY at City College and at our international partners. So the students will be able to gain a lot of foreign experience. They'll attend annual review meetings held in New York City and as well as in those 3 countries of our partner institutions. And each PhD student will have a chance to spend 6 months at these institutions as a research intern. And then they'll also have a chance to visit other partner institutions to broaden their knowledge. Also, industrial perspectives will be provided by our industrial collaborators, SINTEF in Norway, Erstea, this is a national institute, but they do more applied research, and Fraunhofer Institute in Germany. So there is some both academic and industrial input into our project. So this table summarizes how many students will be supported in each year and what kind of foreign experience they'll be able to get. So V stands for visits to research institutions in Europe. INT is the 6-month internship, and all of them will attend this annual review meeting in Europe in years 2 to 4. And they'll be able to gain advanced research experience, training on advanced research tools, both available at City College and in Europe as well. And we'll do some outreach activities. We'll reach out to middle and high school high school students and teachers in New York City. And we'll hold an engineering network reception for science teachers at high schools and community college professors. We'll hold open houses for middle and high school students and general public. And PIA researchers will give seminars and serve as judges and so on at science events. So this is a web page from NSF that made an announcement of the 14 new PIA awards in 2017. And that competition basically received 254 preliminary proposals in September 2016. And out of these 254, there were 68 engineering preliminary proposals submitted, and 71 were invited to submit full proposals. And at the end, 14 proposals were selected for funding. And so the success rate is 5.5% out of the preliminary proposals and 20% of the full proposals. Average funding is about $4.7 million over 5 years. And if we just look at the engineering awards, there were 3 engineering awards, and out of 68, that translates to about 4.4% of the preliminary engineering proposals. So I have some suggestions for anyone at CUNY who is interested in preparing a PIA proposal in the future. So I think I can say that our PIA faculty have had solid track records in research and education over the years. And we built our proposal on strong prior research collaborations, but we had to find additional collaborators to reach a balance in the number of researchers for different topics. So it became a truly multinational collaboration and not a collection of binational collaborations. So the European partners can also collaborate between each other, not only with us, but they will be able to share their facilities and resources with one another. And so the partner relationships need to be clearly defined and explained. So their unique strengths and mutual benefits, as I've shown in the tables before, they should be clearly presented in the proposal, I would think. Additional suggestions, well-planned management structure. I think this is quite an important factor, especially for large projects with many participants, especially involving international partners. So we have appointed a project coordinator, a full-time project coordinator person for this project, and also set up an advisory board, which I will show in the management structure slide. And we do have an external reviewer of our project who has given us very well-defined evaluation assessment metric. So this is our management structure. We have the steering committee advised by the advisory board, and we have, we had to basically come up with the names of people who will be sitting on the advisory board from academia, industry, and one or two more from minority engineering societies. And the day-to-day affairs would be managed by the center management team that consists of thrust leaders from City College, as well as international technical coordinators from different countries for each research thrust. The evaluation and assessment is also an important factor, so we have asked Dr. Dennis Gray from North Carolina State University, who has about 30 years of experience in evaluation of this type of program, to join us. And he also provided us with a well-defined evaluation assessment criteria. So he'll be looking at doing a review of our program every year and examine these 4 criteria annually, and will provide us with the suggestions. Now, the final suggestions, it does require a lot of effort. So we had to spend many months to prepare the proposal, from the white paper to the pre-proposal and to the full proposal. So the full proposal consists of 20 pages of technical and education narrative, plus signed institutional letters of commitment, individual letters of commitment, and since these are coming from overseas, you have to be in good communication with them and have them send these letters on time. CVs of all the collaborators and our faculty, current and pending support, conflict of interest, data management plan, facilities and resources, prior NSF grants, etc. So there's a lot of information that has to be submitted. So extensive and timely communication with international collaborators is a must. Now, John arranged, for us a review of a draft proposal about 3 weeks in advance before the submission deadline, so that we were able to get external review from 3 reviewers, and we received very constructive comments, and we were able to incorporate their suggestions into our proposal, to the final proposal. Now, one last suggestion is to start submitting the final proposal at least 1 day before deadline. Okay, we always do this on the last day, but unfortunately, the NSF's prior submission website was very slow, and it was down on that day. In the morning, it was down, so we couldn't do anything. So we started uploading our files in the afternoon, but as it turned out, we had a single PDF of all the documents, about 200 some pages. Okay, I thought, it'd be a cinch to just upload 1 file. But this submission website requires uploading 1 CV at a time, and we had 28 CVs, and that took more than maybe an hour and a half just for that CVs alone. So we found out, so by the time I finished uploading all the files, it was already past the 5 o'clock deadline. So I said, we blew it. We already passed that deadline. But then as it turned out, because of this server problem, the NSF extended deadline by 2 days, and we were able to submit it on time. So that's all I have to say. I'd be very happy to answer any questions, or individually, if you're interested in preparing a PIA proposal in the future, I'd be very happy to share our experience with you.
We'll take a few questions if anybody has any. Yes.
You talked here a little bit about the process. You say it was many months needed. Can you say how many months, first of all, and what, especially in the early stages, what was your process? Were you taking on 95% of the organization? Did you have someone helping you with the writing? How was all of that managed?
Okay, the white paper was due at City College in the summer, and I think I spent maybe 1 week to prepare it. It was a very short white paper. But we had prior collaborations, so we knew who to include in that white paper. And I think we had 5 white papers at City College, and ours was selected. So then the pre-proposal, though, I must have spent about 2 months preparing it, and then reaching out to other partners that we had not identified previously. So it took about 2 months of effort to prepare a pre-proposal after, and including reaching out to our other collaborators that we did not think about previously. Okay. And then we were selected for full proposal, invited for full proposal probably in late that year, maybe early in January of 2017, and the full proposal was due in April, late April. So we spent maybe 3-4 months preparing the full proposal.
Was it an entire department that was involved, or was it mainly you? Were you having conference calls with all the partners overseas?
Everybody was involved.
Yeah, so I had to get help from our PIA faculty and as well as our international partners to send in all the information that we needed for the full proposal.
So what was unique and what I encouraged is that this not be kind of U.S. France, U.S. Norway, U.S. Germany, and that we all review the proposal together, even the foreign partners. Everybody develop the proposal in concert. And then we would have to deal with, we had weekly meetings for about a year on this. I mean, this is not something that you're just going to put together in a couple of weeks. This is something that needs to be managed. And we need to be providing the time, the resources to do that. You're not going to get a $5 million proposal by just doing it on weekends or spending very little time on it. It took a lot of effort. The other strong aspect here is, scientists, researchers sometimes don't understand the importance of evaluation and assessment. The evaluation and assessment component is going to be reviewed by a panel. And in fact, sometimes it's part of the review criteria. So you better have a good evaluator on that. We had one of the best evaluators on this proposal. This is a guy who evaluated the program, the IUCRC, Industry University Cooperative Research Program. He's been an evaluator on that for 20 years. So that, I think, helped a lot as well.
Did he write the evaluation?
He did.
Yes.
He wrote the evaluation piece, yes.
Yes. Yeah, I just had a quick question. Sunil from the Bronx Community College. During the process of the pre-proposal and the full proposal, what was the time commitment that you got from the grants office? Can you talk about that a little?
I don't think we received any kind of financial, contributions in kind. But we did get administrative help in terms of preparing the budget proposal, budget breakdown, justification, and also checking out all the details of the format of the submission files. So that's really essential in preparing a sort of acceptable proposal.
Now we did ask our foreign partners, can you give us some kind of commitment, or can you tell us what you intend to do? Well, Norway stepped up to the plate fairly quickly. They said, we're going to give you a $3 million commitment on this. And they've already come through with $1.5 million. So that in the proposal, immediately the reviewers say, hey, these people are serious. There's going to be a lot of support. There's no risk in this whole effort. So I think lining all this up front makes a big difference. Preparing this. Yes.
Sheldon Skaggs from Bronx Community College. How important is it to have previous international student grant funding or outreach opportunities for something like this? In other words, having smaller successes that fill it, lead up to this big grant.
It's not required, but it is important.
Yeah, I think some of our PIA faculty have had postdocs and graduate students, do collaborative research in our partner institutions. So there has been some track record in that. So it's very difficult to come up with something completely from scratch.
I've seen many of these proposals in my day at NSF come in, and if you're trying to start from scratch, it's very, very difficult. You have to have really either an outstanding research project that is just, knocks the pants off of all the reviewers, and a very well-developed educational component that, that is very strong. But starting from scratch really is difficult, because I think you need to demonstrate that this partnership is going to work, and that these relationships, they're new, they're risky. So panels are very wary of funding proposals that might not work out. Yeah.
Now, another thing I can tell you is we try to put in as many things that we could do for the outreach. And that really puts a burden on us after we get the funding, because we have to actually follow through with it. But if you don't put that in, we may not get the funding. So I think we did the right thing. We try to put in as many things that we could do, our prior faculty, prior project could do with the high school students, high school teachers, and so on.
So the challenge now is ours. We promised we're going to do this. We have to fulfill the promise. The best way to get more funding is to be successful in the funding that you have. So I think we have to always keep that in mind, that if we're promising things, we have to fulfill those obligations. Okay, I think we need to move on.
Yeah.
Thank you, Masahiro.
Sure.
Thank you very much. I appreciate it. So I'd like to move on. I'd like to invite Michael Mirkin. Michael has earned his BS in his bachelor's degree, his master's degree in chemistry, PhD in electrochemistry from Kazakh State University. He has been a research associate at the chemistry department he had been a research associate at that chemistry department there. He did his postdoctoral research at the University of Texas at Austin, then joined the faculty of Queens College, where he's currently a professor of chemistry. He's been an invited visiting professor at the École Normale Supérieure Paris in 2013. His professional interests are in the application of electromechanical methods to solving problems in physical and analytical chemistry, and include charge transfer reactions at solid-liquid interfaces, electrochemical kinetics and catalysis, and nanoelectrochemistry. So, Michael, are you here? Do you want to use this? Or do you prefer?
Whatever works. Let me try this. Can you hear me? Okay. Thank you very much, John, for the introduction. You managed to pronounce many complicated words related to electrochemistry. Well, my talk will be very different from the previous presentation that focused on institutional aspects of a large-scale collaboration. I will be talking mostly about personal aspects of much smaller collaborations in which my group interacted directly with different groups in different countries. Doing collaborative international research can be very exciting and pleasant. It can also be painful and difficult. And I will tell you a few things that you may be able to use to maximize pleasure and minimize pain if you decide to write a collaborative international grant. Well, first of all, it already doesn't move. Yeah. First of all, a summary of our 4 international collaborations, in which my group was involved during the last 15 years. And as you can see, these were collaborations with Japan, China, France, and Israel, 4 different countries. But my group was always funded by the NSF. My collaborators were receiving their funding from the government agencies in their countries. Okay, still works. And because I am a chemist, my funding was coming typically from the NSF chemistry division. The most recent proposal was submitted 1 week ago to the Division of Materials Research, again at NSF. Well, let's consider these projects individually. No. For some reason it doesn't move. Okay. The most complicated and extensive collaboration was with Japan. In this case, my good friend and collaborator, Takashi Kikiuchi at Kyoto University, was the main person on the Japanese side. The project started when we received a joint travel grant. My travel was funded by the international office at NSF. Takashi received his grant from JSPS in Japan. And 1 year later, I received the regular research grant from NSF that was added to this, well, loosely connected to this travel grant. And 4 years later, another regular research grant from chemistry division, and the travel supplement for Japan from the international office. So it was a long multi-year collaboration that ended when Takashi retired from Kyoto University. On the Japanese side, it involved several other professors. They all came to New York, visited with us, gave lectures here. The travel funds allowed me to go to Japan many times, allowed my students to travel to Japan many times, and we produced together a significant number of collaborated papers published in top chemistry journals. The next grant with China was much more straightforward. It was just the international collaboration in chemistry, the ongoing program at NSF. The proposal was originally written in English, then translated into Chinese, and reviewed independently in the US and in China. The main collaborator, Bin Ren, at Xiamen University, represented the Chinese side. It is actually a large institute at Xiamen University, and the link between us was my former postdoc, who at that point became a young faculty member at Xiamen and greatly facilitated the process. The next collaboration was with France. In this case, my good friend and collaborator, Christian Amator, is at the École Normale Supérieure in Paris. And the funding mechanism was the same, meaning international collaboration in chemistry. And this grant was written in English and reviewed independently in the US and in France. So the two agencies jointly made the final decision. The last project, very recently submitted with Professor Danny Mandler from the Hebrew University of Jerusalem. This funding mechanism is slightly different. This is an agreement between the NSF and the Binational Science Foundation in Israel. The agreement is that there is only one proposal which was submitted to the NSF, which wrote it jointly, submitted it to the NSF, and the Israeli side agrees to accept American reviews. It will be reviewed only in the US, and the Israeli side will accept the NSF funding decision. Either we both will get money or will not get money in this case. Well, I will tell you now about a few lessons that I learned from these collaborative projects, which may be useful for you if you decide to write your own collaborative grants. The first question to ask is to write or not to write. The international collaboration is not for everybody. You have to decide whether you need it or not, whether it is good for you or not. There are many potential benefits. Well, the best thing is probably that you can start doing new things, not only in terms of new research that you wouldn't be able to do without that collaboration, but you also can go to the foreign country and see how things are done there, how people do research, how science is being done there, and this is always interesting and exciting. International recognition and connections is another important aspect. You do get recognized in the country in which you collaborate. You get many new and useful connections. Those people review your papers, those people review your proposals. You can get more collaborations going on, and this all is quite useful. It improves your national and international status. The source of graduate students and postdocs is another important issue. You get sometimes excellent people from your collaborators groups. They come to New York, they work in your group, and this is another thing to consider. And the last and not the least is travel, especially if you are supported by the NSF. The NSF program directors tend to be very nice. They don't micromanage you, they give you a lot of freedom. You can travel in the foreign country, you can give lectures at different schools there. This all is okay for the grant. And you also learn more about the culture, and this all can be quite pleasant. On the other hand, there are problems and difficulties. A typical problem is that the writing process is painful. If the time shift between New York and China is 12 hours, this doesn't facilitate writing. It makes it difficult. And if your collaborator cannot write in English well, this also makes things difficult. And there are other problems like that. There are much more paperwork. And at least in one of my collaborations, that was the real problem. There are logistical issues. If you have to send your samples from US to Japan and back, this is not easy. When Takashi Kikiuchi tried to bring some ionic liquid from Kyoto to New York, the airport security was not very happy with it. There are logistical issues. You have to be ready to overcome difficulties. This is less straightforward than just having a normal research grant. The next point is the choice of a collaborator. Is your collaborator going to be an asset or a liability? This is a very important question, because your proposal will be reviewed here, your proposal will be reviewed in the foreign country. If your collaborator is well supported in his country, if he is well respected in the international science community, that's an asset that improves your chances of getting money greatly. I had all excellent collaborators, absolutely great, and that's why all my proposals were immediately successful. I never had to resubmit a collaborative grant. But if your collaborator is not that great, that may be a liability, and your chances of getting money may be quite low. The next question is your contributions to the project. The research backgrounds must be complementary. You must be able to show that both of you can contribute to the project in a meaningful way. And of course, it's a very important question whether you can or cannot work together. Because you have to work long distance, you have to meet deadlines, you have to write together. People in different countries have completely different ideas about how things are done. And if your ideas about how things are done and your collaborators' ideas are not compatible, that will be a disaster. I knew all my collaborators for several years before I started writing grants with them, and that was a big help. That's why I managed to do this all without getting a heart attack. The next, and okay, it worked in a peculiar way, I don't know why, but the next and the last thing I want to mention is what to include in a small collaborative proposal. One thing, and the very important one, is detailed description of your collaborative approach. The reviewers and program directors expect to see these details, expect to know how you are going to communicate long distance. Will you have group meetings over Skype? How are you going to send your samples? How are you going to do experiments in this country and in the foreign country? How this all will be arranged should be explained in the proposal in considerable detail. The next point is the expected synergy. If you and your collaborator are doing similar things, it will be extremely difficult for you to justify the collaboration. You need to explain that you would not be able to do this research on your own, and your collaborator cannot do this research without you. And this is an important point that has to be written very clearly in the proposal. The last one is the participation of students. The NSF really likes students traveling. Unlike a regular grant in which your travel funds are minimized, In a collaborative international grant, you have to allocate significant amount of money for student travel, and you need to explain in a meaningful way how those students will work in your collaborator's laboratory, how the foreign students will come and work in your group, and give a lot of details about it in order to improve your chances. At this point, I will stop and acknowledge the National Science Foundation that funded all my collaborative efforts, made this all possible, and my wonderful collaborators, Takashi Kikiuchi from Kyoto, Bin Ren from Xiamen, Christian Amator from, doesn't work well, from Paris. Where is Christian? He disappeared, sorry. Well, he's an important guy, a member of the National Academy in France and in many other countries, so it's difficult to get him. And also Danny Mandler. Well, where is Danny? You can see he is very serious, concerned. He is clearly thinking about our collaborative proposal that was submitted only a week ago, and we are anxiously waiting for the results. Thank you for your attention. Yes, sure.
Thank you. Do we have any questions? Yes.
Well, it's more a comment than a question. I think that this could be presented as a case study, and because what you said about choosing the right partner in each country, I don't know the Chinese or the Japanese, but the French, I can testify that he is one of the best in your field, and it's absolutely amazing that you succeeded with all these applications in the different countries, which all are extremely competitive. So all what you mentioned has been instrumental to succeed in 4 different countries and 4 very competitive type of.
Thank you very much. The 4th one is still under review. I don't want to jinx.
Any other questions before we move on? Yes, one question back there.
The funded mechanisms. Well, the main differences between funded mechanisms is whether the proposal is reviewed only here or it is reviewed in 2 different countries, and whether the proposal has to be written in 2 languages or in 1 language. This is significant in terms of your technical approach, how it is done. The funded mechanism, the NSF funded mechanism, is not so much different from the regular research grant, meaning your proposal can go through the panel or through mail reviews. It depends on the program. Of course, if it is a travel grant, it's a completely different story, but if it is just an international collaboration in chemistry, for example, or something analogous in different disciplines, the funding process, as far as I know, is not very different. I reviewed some collaborative proposals as a member of panels at NSF, and they were reviewed exactly the same way as regular research proposals. The funding on the foreign side, or in the foreign country, certainly depends on their system. They can be different. I cannot say much about it. I didn't get so much familiar with the funding system in those countries. As far as I understand, there is almost always a pretty close interaction between the funding agencies in 2 countries. Meaning, if one of the funding agencies is not interested in supporting you or your collaborator, the proposal is pretty much dead. On the other hand, if there is a very strong, enthusiastic support on one side, another side can benefit from it.
So if you notice the prior proposal, the proposal we submitted included 3 countries that were listed on the NSF solicitation as partners with NSF. So we identified countries that in the proposal, and they happen to have relationships with, with the countries that were also had developed relationships with with NSF in their solicitation. So that made it a little easier because then you had advocates from both sides arguing for the proposal. Even though the review panel will evaluate that. They'll take that into consideration. Who is included? Any other questions before we move on to Sunil? Okay, thank you, Michael. Thank you very much. So I think it was a very, very elegantly simple and elegant presentation highlighting some of the most important things you need to think about before you even start developing a partnership. So I think we'll make these slides available to all so that they can have them as they think about these international collaborations. So let's move on to Sunil Bhaskaran, who earned his doctorate from the School of Civil and Environmental Engineering at the University of New South Wales in Sydney. He has been serving as the Bronx Community College as a teaching faculty and a doctoral faculty at the Earth and Environmental Sciences Graduate Center at CUNY. Sunil has mentored over 60 students in focused undergraduate research and collaborated with faculty from different disciplines in geospatial technology, which is still an emerging field. His pioneering efforts in promoting geospatial technology have led to the institutional awareness about its potential. The Bronx Community College Geospatial Center of the CUNY Crest Institute arguably is one of its kind in the CUNY system and was officially opened on October 3rd in 2014. So he'll talk to us a little bit about his international collaboration. Yeah, put it. Oops. Let's do it on this side.
Okay, thank you. Thank you, John. Can you all hear me? Yeah, so good morning, good afternoon. I think it's close to afternoon. I just wanted to thank all the other speakers before me for a pretty outstanding presentation. And I wanted to thank John and all the wonderful work Ingrid did to make this all happen. And thank you, John, for the invitation. So it's an honor and a pleasure to be here. My name is Sunil Bhaskaran, not as complicated as many people sounded to be. I'm the professor and founding director of the BCC Geospatial Center of the CUNY Crest Institute. It's actually a satellite institute under the NOAA Crest Institute, which is administered by City College. So NOAA actually sponsors 5 such institutes across the country, and City College is one of the funded agencies, one of the NOAA Crest Institutes in the whole country. And they've just recently received about $15 million as a part of the renewed grant funding. And we are partners with City College since 2001. Bronx Community College is located in a very historic campus of Bronx, which was earlier NYU campus. And it's pretty historic because we have the Hall of Fame for Great Americans, and we also have a lot of heritage buildings. So I'd actually welcome all of you to come to the Bronx and pay us a visit if you get a chance. I'm going to give it a different twist, this particular presentation. I'm going to talk about how you actually build the blocks for international collaboration. International collaboration doesn't happen in a day or in a year. It's something which has to happen already and has to mature to a certain stage before which you start actually looking for grants. So there are 2 ways to go about it. One is that when you're doing research, you're actually collaborating with international partners without keeping your focus on any specific grant. The other is to actually start afresh, as some of the brilliant speakers have alluded to. And when you start afresh, it's very important to understand the dynamics of the whole thing, just as Professor Kawaji just mentioned, in detail. So I'm going to be focusing on what it takes actually to build these blocks. So my talk will appeal to a lot of faculty who actually wanted to apply for an international grant, but who are not very clear as to what is the pathway. So I think, to me, And in terms of my experience, when I came from Australia in 2008, and when I joined Bronx Community College in 2010, there was not a word called geospatial. So not many people really understood what is geospatial. So we built the whole thing from scratch. So we started the tirade in 2010, and in 2017, we were awarded a grant from the National Science Foundation, close to $1 million, which is about 2 months ago. So I think international research actually begins in your backyard at your respective university. If you are conducting holistic research and you're doing great national research, it's just a matter of time to connect with an international collaborator and start those discussions and expand your horizons. I think it's very important for a faculty to actually not underestimate the value of, not underestimate the value of the student community that you teach. If you foster research in the class, and if you expose them to current research, I think that is the foundation of an international collaboration. So that is precisely what we did in the Bronx. So I and a lot of affiliated faculty, we work with a number of students. And in the Bronx, I don't know how many of you are familiar, there are lots of students who are coming from very compelling domestic circumstances. So it's not like you can actually ask them to come at 2 o'clock and they're going to be at 2 o'clock. Some of them have infants at home. Some of them are socially undermined. They have very low socioeconomic status. And you're dealing with this community, but at the same time, you have to set benchmarks in research. So the benchmarks don't change, but you have to deal and you have to come up with a strategy to teach research to these kind of communities. So I designed a very flexible model where I actually worked around their time. You have 2 options. Either you work with these students or you don't. If you work with them and you are innovative in your approach, in due course of time, you'll see that you're able to publish in peer-reviewed publications and journals. And that becomes a very important factor in looking at international collaborators. So we mentored students in focused undergraduate research. We also published extensively with colleagues and students over a period of time. We submitted proposals for grant funding, and then we showcased our research using smart networks. All these things happened since 2010, so it didn't happen overnight. I have a graphic just after this slide, which will actually show you the progression. So it's important to build your own brand, research investigation, and focus. We are very powerful in terms of what we have, because each and every faculty is quite entrepreneurial. Each one of us have some skills, and it's just a matter of how you shape those skills as you grow in your university, in your particular college. And what's really important to create that core body of researchers is to maintain very high standards of communication and engagement. So this is a schematic of what we actually did. When I came on board, not too many people understood what geospatial technology is. So you can't possibly put your hand up and say, I want a center in 2011. That's not going to happen. So it's very important to relate to your community. It's very important to make them aware of what this technology is and bring them on board. Again, that process cannot be shortened by giving a lot of flyers and pamphlets. You really have to be in the thick of the action. You have to talk, you have to interact, you have to give multiple seminars, you have to give a lot of workshops, you have to go and reconfirm what you said, and of course you have to deal with administrators who sometimes change very often. So what we did was we created a lot of awareness workshops, both to the faculty and staff and to the student community. We worked on a lot of informal projects with approximately 100 students were actually mentored. And in 2010, I did not even have a geospatial computing center or a lab. I just had a small space, which is probably just the amount of space I'm standing here, and 3 computers. And that space was frequented by students from different diverse communities. So we managed to channel their interest towards entrepreneurial research which is current, and we got them interested. Again, that was not easy. The initial reaction by the students was of fear, of angst, of uncertainty, but we broke through the barriers by working with them constantly. And eventually, the same students went to conferences. When they came back, they were very proud. and they had a different brand of self-esteem. So we also ended up, I'm very proud to say that 4 of my publications were actually co-authored with students from the Bronx Community College, including one which was published in the NASA Journal. And a lot of students still participate and have participated in conference, and they have a lot of publications and proceedings of conferences as well. And on this foundation, we can now look and try to expand our horizons and look for international partners. If we don't have a solid foundation, it's going to be very difficult to have a relationship. Dr. Howerton mentioned how important relationships are, especially with international collaborations. So I think it's very important. And I must also mention, from the time 2012 to 2017, we secured numerous grants. The NSF, we only got it in 2017, but we had grants from the federal industry, we had federal government, federal industry, and many others. Some of the grants came from CUNY, some came from the college, some came from the industry. Digital Globe Foundation is one of the biggest foundations in the whole world. They are the ones who make satellite images. I must say that my field of study is in geospatial technology. So the main aim of geospatial technology is to decompose a pixel on the satellite. So every pixel on the satellite represents a portion of the Earth. So we use different innovative techniques to derive information from that pixel. That is the science of geometric engineering, where I have a PhD in. So we got grants from ESRI, who are one of the largest geospatial companies in the world, stands for Environmental Systems Research Institute, and CUNY has a contract with ESRI. We are using ESRI software. And we also got grants from RapidEye, who have been acquired by Planet, which is a company, RadarSat, Harris Corporation. I just had a meeting with them 2 months ago in Denver, where we were talking about designing out-of-box internships. Typically, you see that interns travel to a certain destination and participate in internships, but we were talking about remote internships, where a person doesn't actually go there, so you're saving up a lot of effort on logistics and money, but at the same time, you're exposing that particular candidate to the workflows in the industry. We also had federal government grants from the Federal Highway Administration and US Department of Transportation. We ran a very successful National Summer Transport Institute, where we trained about 50 students in a week's time about the applications of geospatial technology into the transportation sector. We're also working with Australia, and in the Smarter Cities project, we collaborate with IBM, and a person who actually started the whole process is sitting right here, Professor Neil Phillip. I think way back in 2012, we had visitors, mayors from Australia visit us, and then we had reciprocal visits, and we have a strong relation with them.